So inorganic compound A and B contain the same group 2 cations but different anions. So two compounds are there, they contain the same group 2 element but the cation is different. Anion is different, sorry. And the two tests were carried out in A and the observation are made for each test tube and recorded in the table. Complete the statement in the inference column in the table by writing the names or formula. So you can write name or you can write formula. So the first one, when we add dilute sulfuric acid H2SO4, we got white PPT. Two possible cations. So if we add sulfuric acid and we are getting a white PPT, so it means because it might be barium sulfate, because the barium when it reacted with sulfate it will give white PPT, or it might be calcium sulfate because we know barium, most sulfates are soluble except calcium, lead, these are insoluble sulfates. Like all nitrates are soluble, most chlorides are soluble except silver, mercury, and lead. Most sulfates are also soluble except barium, calcium, and lead. So, what might be the possibility if you're adding H2SO4 and they already mentioned these are group 2 elements? So, might be a calcium compound or it might be a barium compound. So if it is a calcium compound, it will give calcium sulfate, will get a white PPT. If it is a barium compound, we'll get barium sulfate, that will also lead to white PPT. So when we add dilute sulfuric acid to aqueous solution of A, it will give a white precipitate. So two possibilities are, it might be barium or it might be calcium or calcium. Then a sample was heated in a test tube. The brown gas is evolved. So brown gas is only released when nitrates are heated, because when you heat nitrate, it will give metal oxide plus nitrogen dioxide plus oxygen. So a sample of A was heated in a test tube, a glowing splint held near the mouth. The splint relight. So what did this give an idea? Because thermal decomposition of a nitrate or metal nitrate, generally they decompose into metal oxide plus nitrogen dioxide plus oxygen. The brown gas is nitrogen dioxide and glowing split relined due to oxygen. So anion present in A. So which anion is present in A? It is containing a nitrate ion, so NO3 with a charge minus. So there were two gases evolved when A was heated, a brown gas C and D, which relight the glowing split. Identify the gases. So what are the gases? Like two gases are there as we already discussed. Whenever we heat metal nitrate, generally it decomposes into nitrogen dioxide. So brown gas is nitrogen dioxide and the gas D is oxygen, which relight the glowing splint. Because oxygen support combustion, the glowing split will relight. Name a test that could be used to distinguish between the cations identified in A and include an expected result for both cations. So we in the beginning we said it might be barium, it might be calcium. But how to distinguish whether it is a barium or a calcium? So what we can do, we can carry out a flame test, and then if it was a calcium, it will give a brick red color flame, and if it was barium, it will give apple green. So possibilities, what are the possibilities here? Like what we can do, we can carry out the flame test and space is given. So you can mention all the points. With calcium, it will give brick red, and with barium, it will give apple green. So these are the observations. Like using the flame test, we can distinguish the two positive ions. Then test was carried out in B. On B we carried out, so we already identify, we did not even, it can be barium compound or it can be calcium compound. The observation made, complete the statement in the inference column by writing a formula. So see, right now you are only supposed to write a formula, we are not supposed to write the name. The concentrated sulfuric acid is added, orange brown gas was evolved. What could be the formula for B, for anion present in B? So when we are adding a sulfuric acid H2SO4 and we observe a brown gas. So basically this gives an idea, because sulfuric acid, it when it reacted with a bromide ions are good reducing agents, so they reduce the sulfur to +6 to sulfur dioxide SO2, which will have a oxidation number of +4, and it will produce a bromine vapors or bromine gas. So that's the reason of a brown gas. So what might be in B? B might contain bromide ion, and either it will be calcium or barium, we don't know. But when we add sulfuric acid H2SO4, bromide ions are good reducing agents, so they produce sulfur dioxide and bromine molecule. And this bromine is responsible, that's the orange brown gas which is given over. The formula of the anion present, so what might be the anion? The bromide ion, the anion which is present in this compound B. Then identify the orange gas, that's a bromine gas. Bromide ion is there which is present in B, and the gas which is given off is a bromine gas. The two colorless acidic gases were also evolved in B1. So because we know bromide ions are good reducing agents, so when they react with sulfuric acid, as a result what it might produce bromine molecule and sulfur dioxide. And it might also produce bromine molecule and sulfur. And the second thing, first, because there is an acid base reaction, so when like this calcium bromide is there or barium bromide is there, when this element is reacting with sulfuric acid, first acid base reaction might occur, so it might give off HBr as well, hydrogen bromide. So sodium, the metal hydrogen sulfate will be there plus HBr. That's the first thing. And this HBr which is released react with sulfuric acid and leads to multiple products such as bromine molecule or sulfur. Not hydrogen sulfide gas. Hydrogen sulfide gas is only produced when it is a iodide ion, which is a better, a strong reducing agent compared to bromide. So the two gases were dissolved in water. The aqueous silver nitrate and dilute nitric acid were added to a solution in a cream precipitate. Give a name or a formula of a gas identified in this method. So if it is giving a cream precipitate, so which was the two gases, basically the two gases which are given off, one is HBr, another one is sulfur dioxide. Both are acidic, hydrogen bromide, hydrogen halides, all are acidic. So hydrogen bromide is acidic, sulfur dioxide is also acidic. But how to identify which one is hydrogen sulfide or hydrogen bromide or sulfur dioxide? So when we add silver nitrate, because as a result, when we add silver nitrate, it will produce silver bromide. So silver bromide means it's coming from hydrogen bromide. So name or formula of the identity of a gas by this method. So by this method, we can identify the gas was hydrogen bromide. Because as a result, this hydrogen bromide mixed with silver nitrate, it will form silver bromide, which is a cream precipitate, and hydrogen nitrate. So this AgBr will give a cream PPT, and that cream PPT is due to the presence of HBr gas. That's why we identify by this way. We can say that hydrogen bromide gas was there. Then the second part, how to identify the second gas, sulfur dioxide. So we can test sulfur dioxide with by acidified potassium dichromate, and it will turn from orange to green. So the acidified potassium dichromate, when it is suggests the identity of other acidic gas, so that is sulfur dioxide. Directly we can write SO2. So experiments were carried out on a sample of hydrated calcium nitrate CaNO3 in a bracket 2, then 2H2O, the water of crystallization are there. Describe how to carry out a flame test to show the cation present in the sample and give the expected results. It's a 4 marks. So how you score 4 marks? First thing, you will take a nichrome wire or take a clean nichrome wire, that's 1 mark. Then you will dip in a concentrated HCl, that is a second mark. Then take the sample and place it on the hottest part of the flame, that's the third mark. And then at the last, what is the observation? It will give a, because calcium is there, so it will be brick red. So we'll take nichrome wire, we will dip in HCl, concentrated HCl, we will take the sample and place on the hottest part. And then what is the observation? The expected, it will be brick red because there is calcium ion, so which leads to a brick red flame color. Then part B, calcium nitrate crystals are heated gently in the test tube. Fumes which look like steam were given off. Then give a name of a substance that could be used to test the presence of a steam in the fumes and describe expected color change. Because it's a hydrated salt, when we heat hydrated salt, it gives water. And how to test the presence of the water? We can use anhydrous copper sulfate, or we can use a cobalt chloride. It will turn from, or we can use a cobalt chloride paper, it will turn from blue to pink. So any one of them you can mention the substance which you can use. You can use anhydrous copper sulfate, and as a result this anhydrous copper sulfate will turn from from white to blue. But for it was cobalt chloride, it will turn from blue to pink. Then on further heating, a sample and a mixture of two gases was evolved. One of the gas was colored and the other was colorless. Identify the colored gas. So whenever we are heating a nitrate, it gives off nitrogen dioxide, and nitrogen dioxide is a colored gas. So the sample, when we are heating, it means further heating of a sample give off two gases. And in the beginning, you can see in the question they mentioned it is a nitrate, calcium nitrate. So when you heat calcium nitrate, it will give off nitrogen dioxide. So identify the gas. One, the colored gas is nitrogen dioxide because it's giving off two gases. One of them is colored, which is NO2, and other one is colorless, oxygen. So identity of the gas, it's NO2 or nitrogen dioxide, and color of the gas, that is brown. Nitrogen dioxide is brown in color. Bromine vapors are also red brown in color. Identify the gas in the colorless gas, so that is oxygen, and test and observation. So glowing split with oxygen, it will relight or rekindle. Then a white solid remained after decomposition, because when we supply heat energy, the white solid, that will be calcium oxide. Complete the equation for thermal decomposition of hydrated. So when we are supplying heat energy to metal nitrate, hydrated metal nitrate, it will give metal oxide plus nitrogen dioxide plus oxygen, and also the water of crystallization will be lost. So calcium nitrate decomposed to calcium oxide, white solid, nitrogen dioxide, the brown gas, oxygen, which glowing split relight, and the water of crystallization are also given off. Then we have to balance. For balancing now, calcium is already balanced. What about the nitrogen? We have two nitrogen because it is NO3 in a bracket 2, so we put 2. Nitrogen is balanced. What about oxygen? Don't bother about this water because that is already removed. So 3 to the 3 multiplied by 2, 6. So we have 2 multiplied by 2, 4, 5, 6 and 7 are there. So we want to remove them because we want to make 6. So 2 multiplied by 2, 4, 5. So I need only 1 here. So I can have half oxygen, or molecule, or one, it makes 1 oxygen plus 4 plus 1. So total will be 6. So this equation is balanced in terms of all the elements which are used here or which are present in the equation. A white solid which remained in the test tube was allowed to cool down to room temperature. A distilled water is added. So when we add calcium oxide is there, we add distilled water. Give a name of a solution form when distilled water was added to white solid. So calcium oxide plus distilled water or water. So as a result, it will produce calcium hydroxide solution. Calcium hydroxide solid is called a slake lime, but when it is dissolved, it is called a lime water. So you can mention a lime water, and this solution is used to test the gas. So which gas we can use? Like which gas can be tested with the lime water? So that is a carbon dioxide. So CO2 or carbon dioxide is tested with a lime water.